Hi students, in our previous lecture we have understood what is meant by uniformly accelerated motion. If the acceleration remains constant. Acceleration is remaining constant means change in velocity in equal intervals of time will be same. Such a motion is known as uniformly accelerated motion. A remains constant. Do you remember? A remains constant. The equations of motion that I am going to derive here, they appears to be valid only for one-dimensional motion, but we can extend those equations even for any dimensional motion. That is for two-dimensional motion. Two-dimensional motion means the motion which happens within a plane, and also for three-dimensional motion. Three-dimensional motion means which happens within space, isn't it? Anyway, how to extend I will discuss it later. At this stage, let us try to understand the equations of motion for one-dimensional motion with constant acceleration. Do you remember I told you, if a body is traveling along x-axis, let us suppose, at t equal to 0, the velocity of the body is u. Means the body has started its journey with an initial velocity u. After some time t, let us suppose its velocity has become v. That is, at t equal to t, its velocity has become v. We know the definition for acceleration. Definition for acceleration is change in velocity. Change in velocity means final velocity minus initial velocity divided by time interval. Time interval will be t minus 0, implies acceleration is equal to v minus u by t. I am bringing t to left hand side, implies v minus u is equal to at, implies v will be equal to u plus at. Is one of the equation of motion. V is final velocity, u is initial velocity, a is acceleration which remains constant, t is time. You remember this format of the equation is valid only in the cases where a remains constant. If a doesn't remain constant, we have to go for other format of the equations. About that we will understand after learning calculus. Now, final velocity you can find out if you know the initial velocity and acceleration and the time at which you want to measure the velocity, which is important equation. Next thing that I would like to calculate is average velocity. Average velocity, V average, which will be equal to. Do you remember how to calculate average velocity? Average of any two parameters, final quantity plus initial quantity divided by 2. Average of two numbers, 1 plus 3 divided by 2. Similarly, average velocity will be equal to V plus U by T. You keep this average velocity with you, this expression, because I will take the help of this expression while calculating the displacement. Do you remember how to define the average velocity? I have defined it. Displacement divided by time interval implies displacement will be equal to V average, that is average velocity into time interval. Time interval will be t, because the interval of time that I have taken to be equal to t minus 0, which will be t. Displacement I am indicating it with letter S. We know average velocity will be v plus u by, I'm sorry, I made a mistake. The mistake is average velocity is v plus u by 2. The average of two quantities will be measured. Yeah, you try to understand? 2 you have to use here, not t. Now, I am substituting v plus u by 2 into time interval will be the displacement expression. Now, I will modify that expression into the required format. S will be equal to v plus u by 2 into t. We already know v equal to u plus at. I am substituting v equal to u plus at here. U plus at plus u by 2 into t. which will be equal to 2u plus at by 2 into t. You bring t inside, it will be equal to 2ut plus at square divided by 2. You divide it with 2, then 2 gets cancelled, so it will come as ut plus half at square. So the displacement expression will be s equal to ut plus half at square. This is one more equation of motion. That is one more equation of motion which is also very important for us while solving problems. And the third equation of motion that I will take up is relating the same parameters. We know in our hand we have acceleration to be equal to v minus u divided by t. Acceleration you have in your hand, and I would like to get the expression between v, u and a and s. You think how to make the relationship between them. We know already in our hand s equal to ut plus half a t square. That is one more expression. We know already v average is equal to v plus u divided by 2. That is one more equation. And displacement will be equal to v average into t. That is one more equation in your hand. Out of them, this is very important for us, and v equal to u plus at is very important for us. Implies I will take the help of s equal to v average into t. S is equal to v average into t, which is equal to v average. We already know v plus u by 2 into t. T, I will get the expression for t from here. T I will bring it to left hand side, a will come to denominator, which will be v by u divided by 2 into t will be v minus u by a, which is equal to v square minus u square divided by 2a. That is one more important equation. You see here, the other equation in our hand is s, which is equal to v square minus u square divided by 2a, implies v square minus u square is equal to 2as. Is one more equation of motion which is also very important for us. So the three main equations of motion are v equal to u plus at, s equal to ut plus half at square, v square minus u square equal to 2as. Understanding each and every term in those equations and understanding how to apply those equations to a physical situation is very important while solving problems in physics. Apart from this, of course, people will consider one more equation is there, that is for displacement in nth second. They will treat that also as equation of motion that I will discuss at this stage. I am very much interested in concentrating only on these three equations. V is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as. These are the three equations in our hand. In it, v will be velocity at a time t, u will be initial velocity, s will be displacement, a will be acceleration, t will be time. While solving problems, you remember that you have to make use of the same sign convention that we made in our previous lectures. What is that sign convention? Do you remember? I will repeat it again. If particle is moving along plus x-axis. If the particle is moving along plus x-axis, displacement is positive and velocity will be positive. If particle is moving along minus x-axis, then displacement is negative and velocity is also a negative. And then in case of accelerated motion, do you remember I told you both velocity and acceleration will have same sign. Acceleration, velocity will have same sign. Means if velocity is positive, acceleration has to be taken as a positive. If velocity is negative, acceleration has to be taken as a negative. In case of retarded motion, acceleration, velocity will have opposite sign. So in case of retarded motion, if velocity is positive, acceleration will be negative. If velocity is negative, acceleration should be positive. These three equations in combination with this sign convention will solve any complex problem.